So what is Delta Lake? So sir has taught about the theory, right? Can anyone answer what is Delta Lake?
Open source storage.
Okay. Any more points on that?
Which resides inside the lake house
Hmm.
in the form of Parquet files.
Okay. So that's right. Okay. Anyone else?
Data file stored in delta format.
Yeah, right. In the Microsoft Fabric Lakehouse, right, is based on a Linux foundation, which is called as a Delta Lake in a table format. So this is stored as a Delta tables, and this format is mostly and specifically used for Apache, used with Apache Spark for Spark processing and all. And moving forward, and as one of them told, Delta Lake is an open storage layer for Spark that enables the relational databases for batch and stream processing capabilities. So if you have stored the data in this relational databases, then it is easy to load the data and save the data in the form of Delta format. By using Delta Lake, we can the whole Delta Lake supports anyways the SQL commands and the SQL query language. So it is more usage of both Spark and SQL in a single platform. Where you'll be seeing how we'll be using both SQL and the PySpark in a single notebook. Here's what the specialty of this Delta Lake is, where the data is pulled from a single location and you can manipulate the data or you can work with the data over there. So all of this, the outcome of this Delta Lake is like the analytical, like the analytical data or the analytics, whatever we get insights from the data, is most of the time pulled through these data tables itself. So let me start with the hands-on. So you guys are clear with the Delta Lake and Delta tables, right? Am I audible?
Yes, sir.
Yeah, yeah, yeah.
Okay. So first thing, whatever hands-on we do, first thing is we need to create a workspace. So I'll be creating a workspace with the name Delta Storage Delta, and I'll just leave these things blank and I'll just click on apply. So I have created a new workspace called Storage for Delta. Now I will be sharing you a file over the Zoom. So this is our workspace. So first thing is inside our workspace, we are going to create our data item, that is the lake house. I'm just going to search here for a lake house. Here it goes. And I'll give a name to it. Lake 1 for Delta. And I'll create under this workspace itself. This will take a minute or two. So today's hands-on agenda will be, so first thing is creating the lakehouse and uploading the data. Then we'll explore the data using Spark. Then we'll create the Delta tables, and we will see the managed tables and the external tables as well. And then we'll be going to use SQL to create delta tables, that is basically managed and external tables. Then we'll see how to analyze the data with SQL queries. And if time permits, we will also go with the table versioning of the data. So first thing, we have created a lakehouse. Now we will upload the files to this lakehouse. So as usual, I'll create a folder inside a subfolder within the files as data, and so it looks organized. I'll upload the data inside this folder. So I'll just take it from my local system. It was getting uploaded to the lakehouse. So now the data is uploaded into the lakehouse. rename this as products instead of data. So that because it's a product data, right? I'll just rename this as. Any questions on the data set?
No.
Okay. So I guess everyone understood the process till here. It is the same old process which we have gone through in our previous classes. Only the data set is different. And the next step is we are going to explore the data in a data frame. So in order to explore this data in a data frame, we need to use the notebook. So we have a notebook option over here in the top menu. So click on it and you will see a new notebook or existing notebook. So as of now, I don't have any existing notebook. I'll be going with the new notebook and I'll be naming it as, I can just skip the store for now. So let by default, it'll be saved as notebook one. So I'll just leave it as notebook one for now. So I'll just explain you this interface before running through the actual code and stuff. So this is a similar platform like Jupyter or a Databricks notebook platform where the Spark is integrated to this environment. You can see over here. So if you want to directly work with only Python, you can only work with Python. If you want to work with only TSQL, you can work with TSQL. So Spark can work with Scala as well and R as well and Spark SQL as well. There are these many options over here. You can choose whichever you need, but I'll be going with PySpark as of now. And environment, it'll be what see the Spark configuration over here. So if you want to change the environment, you can go here and change the nodes and all the settings over here. As of now, due to this trial account, we'll be using the default setup with the compute as medium and whatever the default settings is available for us. So these are the important things, and this is to run these cells and this is a connect button that connects to the Spark session. So here you don't have to write the Spark session code. Once you click on this, this will automatically connect to the Spark session in the backend, and you can just directly import the libraries and start working on your code. So this is again the saving your notebook. So I can save the notebook as Delta tables notebook. So now on the left hand side, you can see the data items. Data items are nothing but the storage spaces. So here we have lake one for Delta. That is the lake house which we have created. Under that, you can also see the tables. So as of now, I have not converted my file, the product file into tables. So you are not able to see anything under this table. And there is a data. If you just click on this product data, you'll see the files under that subfolder. And these are some resources that are built in. So you can just, if you have any built-in resources over here, you will be able to see this. I'll get back to this bit later. So now the first thing is, well, as soon as we create a notebook and open it.
Yeah, now, okay. Can you explain the connect one? But at that time, it was very feeble.
Okay, I'll be explaining it along with the process. Is that clear? Still, I have not connected it. When connecting it, I'll be explaining it what it is and why the button is here. We have a notebook interface in our Fabric. So now I'll be directly entering some comment. So what we are going to do is we have to create tables using Delta where the data is stored in the lakehouse. So you will be seeing all the functionalities of the Delta Lake. Explore the data lake functionalities. So the basic commenting thing is you can use a hash for a single line commenting, and for multi-line commenting, you can use hash star. I guess so. I'm not tried it, so you guys can use it and try it. But most of the cases, our commenting will be in a single line. So here I can also make this as a heading by using the markdown button over here. So if I click on this convert to markdown cell, this will be converted into a heading. So we will get the options to bolden it, and you can even underline. You can either go to the italics. You can make the font size, the different sizes of font size, or you can even add a link to it. So it just acts like a text box over here with all the functionalities over there. So next thing is first thing is I'm going to connect to the Spark session. So what happens in a regular PySpark on your local system is you will have to write a set of Spark session code to start the session. But over here, the Spark session will already automatically be created in the backend. You just have to click on connect. So this connect to the normal session which is available. So I'll be using this new standard session. Once you click on it, it will take normally 1 or 2 minutes to get connected to a session. So as soon as I click on it, I could see it has been connected to a standard session in the backend. If you want to stop the session, you can just click on this button, the red outline with the square mark. So if you just click on this, the session gets stopped over there. So, and now I'll be using the PySpark, that is the Python plus Spark, that is PySpark, work with the data. So first thing is I will import some of the things. PySpark.sql types, and from this function I think import struct type and integer type, string type, and double type. So let me go with these things as of now. Now I'll be defining the schema for the data. Schema will be struct type. So first column will be product ID, and then the data type followed by its data type, that is integer type, and the same thing. I'll just add the product name instead of product ID for the second column. If you open the data set and see, you will be able to see this columns. So I am just naming it accordingly. So it is a string, product name is a string. So I'll be using the string type. And then the column is category of the product. So again, it comes under string type, and the last one is the list price. So this comes under double type, which we imported from the PySpark SQL types. Now we have defined the schema. Now we need to read the data into the schema. So to run the cell, you can use this just run command. So this will run. For the next set of code, yep. So the schema has been created now. Now we need to ingest the data into the schema. So take a new cell with the code. So we are just giving the code. So we'll be using that option. And for our data frame, you can give any name. As of now, for the data frame, I'll be giving it as df. To read the data into the data frame, we have a syntax. I mean, we will be following a syntax. that is spark.read format. So the data is in CSV format. So I'll give it as CSV. And then I will tell let us option as it has already, it has a header. So if it has a header, then I'll be using this a dot option function in the same line. Otherwise, I can skip this if it doesn't have any heading. The schema, the whatever we have created here will be taken as the heading if we don't have that. But now I'm telling whatever the header is there, we should be taken as the schema. So it will be schema, and this you can give any name for this, but I have already given the name as schema for the thing. So I'll be using the same over here and loading it into the, so we need to take this file location. In order to take the path of this file, you can just click on this three dots and you can copy the relative path for Spark. So once you copy it, and you can paste it over here. So this will fetch the data from this files, product data and product.csv, and load it into this schema whichever we have created earlier. So I'll just run this cell. So the log has been generated. Whenever this log has been generated, it means that our data has been executed successfully. So I'll take to the next cell. So I'll just display it and check whether the data has been placed properly or not with our schema. So the Spark job has been started running in the backend. So it means that the data frame has been created. So you can see that the product table has been created. I mean, the data frame has been created successfully.
Can you show me the product.csv file before applying the schema?
Okay, you want me to show the file? Just a minute. Are you able to see it? Okay. Now, I hope you are able to see it now, right?
Yes.
Yes.
I have a question about this file.
Hmm.
Because here we have only 4 columns, right? Product ID, name, category, and list price. Then why are we creating the schema there? Why are we creating the schema over there? Because there are only 4 columns here, and we are also creating 4 columns in schema.
Okay, what happens over here is the data type of this column would not have fit to
The
the
restrictions.
yes, yes.
Yes,
If you want the data to be in int or float or double, this will not be taken automatically. So
if we load that CSV file inside the PySpark and we don't create the schema, then this is, I think, float. Then
yes, it will be taken as float, or sometimes what happens, the CSV will consider these numbers as well as
integer
string. So
string. Okay.
yeah, so in order to avoid all these complications, it's always recommended to create a schema and then work with the data.
So to create a schema, we should be aware of the columns that are presented that are in our CSV files before we create the schema, right?
Yes, yes.
Thank you very much.
So any more doubts? Can we proceed further? I hope my screen is visible, the Fabric screen.
Yeah. Yes.
Okay. Moving further, now we have seen how to create a schema. Then we ingested our data through the schema, and we have displayed it, and we know how to create a data frame. Now, this was a part of a notebook, how to create a data frame. Now, okay, the data is in data frame. You perform all the operations either in the data frame. And now to save this table in the form of delta table in the same data lake. So it can be done using this first thing is you should know how to create a delta table. So now I'll just show you how to create the delta tables. So delta tables are of two types, that is managed and external. So managed delta tables, no, like they benefit from the higher performance as Fabric manages both the schema metadata and the data files. Whereas the external data files, no, allows you to store data externally with the metadata managed by Fabric. So first thing is we'll create managed table for this product CSV. Okay, to create it, I will have to write, I'll have to use a write format. So how we do it similar to this, that is df dot write dot format delta, and I will save as table, and I'll give the name as managed product. I'll just run this. So this will write the data in a delta format, and it will create a managed delta table. So here you will be able to see it. This will take a few seconds as it has to convert the data frame to the delta format. So here, if you refresh the link, you can see the managed products table has been created for the same data. So you can see the columns over here as well. So this is how you can save the data in a delta format. And for this, have taken the process of managed table. The way I have chosen to create a table is manage delta table. In the tables folder, you will be able to see the same table, whichever I have created over here. Does anyone have doubts over here? Creating the managed tables?
Yes, earlier in product data that is inside our lake one for delta, then we click on that product data, then product.csv, then we right click on that, and then new table, then later the delta table gets created, right?
Yes.
Okay, that was the manual way.
Yes, that was a manual way. I'll tell you
Okay.
when that is used and when this is used. That is just to only preview the data. We'll be using it over there. Here, I have not shown any transformations as of now. Suppose you add a column to this data frame and you want to save this data frame in the form of delta. You think this data has undergone some transformations. There are some changes in the data. You have done all the transformations using PySpark, and now you want to save the transformations, transform data. That time we'll be using this managed tables format to save it as a delta format. Whereas in the lake house, you can't directly
Okay.
do that. So I guess the doubt is clear. Like that is
That
a
is
very
just for
manual thing.
viewing the content.
Yes, that is only for the preview purpose.
Okay. Once that preview purpose delta table gets created, then we can remove that, and then later we can transform the file using PySpark, and then we later save it as a delta table, right?
Yeah, we can do that. We can do that. And one more thing I would like to tell over here is whenever we create a manual way just to preview the data, no, you can check with the column names over there and check the column names and also the data types along with it. So if you feel the data types are not appropriate to the column, you can change it while you're creating the schema.
Okay.
So that is one way like which you can get a reference to create a schema.
Okay.
Okay. So that was about managed tables. Now it is about external tables. So I'll just give a markdown over here and write it as external tables. So in order to create this external table, we will be using the ABFS path. So where to store this table externally. I don't want to save this in this path. So I want to save it in different file system. So what I will do is it is also the same syntax. So I'll just give df dot write dot format delta and def as table. I'll give the table name as external product and I will have to give the path over here. So whereas in the manage table, I did not give any path because it was stored within this lake house itself or within the tables format inside this lake house. So now I'll be giving the ABFS path. So either what I can do over here is I can create a new lake house with the lake house name as lake to external lake. Better this name external lake. So you can think this is a separate lake house inside the same workspace. And if you refresh all the things, so I have created a lake house within the same workspace. So here I'll be creating a subfolder called external data. External data store. And I'll just click on this and I'll take the ABFS path of this. I'll copy the ABFS path of the whole lakehouse. So now lake 1 for data is a separate lakehouse, what we are working in, and I have created a another lakehouse inside the same workspace called as external lake. So if I go to my workspace, so if I go to home workspace and click on this, you'll be able to see two lake houses, that is external lake and lake for delta. So I'm working over here inside this lake for delta. I am working on this notebook. So I'm going to store this data in this external lake where I have created a folder. So that is what we are going to do now. So I have copied the path, ABFS path for this. It is Azure Blob File System path. ABFS refers to that. And I'll be just pasting the path over here. And I'll be running this cell. So now the data will be stored in the delta format inside this folder. That is the other external lake inside the external data store folder in the packlet format. So you can see over here, this is the file which I have stored it as an external table. So you can also see the table over here, I guess.
So we can store the external table inside any other lake house
Yes.
or any other cloud service provider. Can we store it locally in our computer also?
Locally in our computer, it is not possible. You can store it only in the external.
Cloud.
So suppose if you are connected, if one kind of workspace is connected to your Fabric environment, yes, then it is possible.
Sorry, I didn't get it.
If you have an API connection to your Databricks or any other cloud resources,
Okay.
then obviously you can store it over there by using the path. So there will be a different path for it. It will not be a ABFS path. It will be a separate path to it. You can just give the path over there and it gets stored over there in a delta format, in a packlet format, open delta packlet format. From here, you will be able to load the data into the table format as we do it in the lake manually. Or if you want to, again, if you're working somewhere else in the some other lake or workspace, you can load the data using the Spark by creating the schema, or if you want, you can use the same schema over there. So this is the delta log, which contains the JSON files. So it also tells the statistics and the commits done to this particular external folder or the file. So this is how the managed and the external tables are created. So managed tables are just created within the current lakehouse. So if you want to store the data somewhere out of the lakehouse, then you can follow this procedure. So you guys are clear with the managed tables and the external tables now? Are you guys there?
Yes.
Okay. So now I'll be comparing both managed and the external tables. So by a snippet of code. So now, until now, whatever the code I have written was in PySpark. So now I'll be writing a SQL code inside this note book. So this will turn this cell into Spark SQL from PySpark to Spark. So if I remove this, it is PySpark cell. So if I just give this percentage SQL, this will get converted into a Spark SQL. So you can also choose it over here, whether you want a Spark SQL or a Spark Scala or PySpark for this. Did you guys get this? This is called as a magic command in a Spark processing. So now I'll be describing the managed table. So managed table, I have named it as managed products. So this will give the details of the managed products table. So you can see it will give the data type of the columns present in it, and also the location properties of the table, and what is the kind of storage it is, whether it is a managed type or an external stored. You can also see it over here, and the name of it, name of the table. So whenever the name has been stored, we'll store it as managed products, but the whole name is Spark. It stores in a Spark catalog under a lake with the lakehouse name dot the table name. So this will be the ABFS path for one lake, the whole one lake path, and you can also see the table properties and the owner. So this is how it is going to describe the table. It is similar to the SQL commands, like how you describe the table in SSMS or anything. It is similar to that. Now I will do the same thing for the external table. So external table, I have put it as describe that external product. So let me check what I've given earlier. It is external product. So once I run this, I'll be able to see the table details that is present external to this lakehouse, and you can also see the same details as we have seen here. Here you can see the type is managed, whereas here you can see it is external. So it is showing the data that is present over here, and the managed table was the data that is present over here. So you can see the provider, that is the delta. It is the storage format is delta, and it is the ABFS location of this space. So this is the comparison of both the managed table and the external table. I mean, both the tables dropped, you will not be able to see the files over here. So if I refresh this, so the tables are not there now. The tables will not be existing here. Clear till the creation of managed tables and the external tables and comparison between the two. It's good to wind up the class for today.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.